All right, so this is going to be self-check 1.1. I just want to give some instructions for the students that were not here. The way that we did self-check 1.1 was we gave ourselves 10 minutes, which is about 2 minutes per question. And at the end of the 10 minutes, we stopped, and then we're going to get this review. So here goes the review. Number 1. So we take the limit as x goes to -3. Let's change to our pen here. When we plug in -3, we get -3 to the power of 2 plus -3 minus 6. All of that divided by -3 plus 3. We immediately see that's 0 over 0. So, class, what do? When we have 0 over 0, there's always 3 things. Factors 1.
Factor, cancel, plug in, right?
Beautiful, yes. These are our 3 steps over and over again. Factor, cancel, plug in. Perfect. So I'm going to factor it. No, I'm not. I'm going to make you factor it. Guys, tell me what it factors to on the numerator.
X minus 2, x plus 2.
X minus
I mean,
2,
x plus 3.
x plus 3. Thank you, Carly. Does anything happen in the bottom?
It's just x plus 3.
Says x plus 3. All right, I just did step 1. Someone else do step 2.
No, cancel.
Cancel what?
X plus 3, x plus 3.
All right, so those go away, and I'm left with just x minus 2. I should be clear here. When I'm canceling this out, I should say that this is still the limit as x approaches -3. I don't just take the right-hand thing. I still have to rewrite the limit over and over again if I was doing this as a free response. This is multiple choice, so no one cares. And when I actually do this, I'm on step 3. I plug in, and what do I get?
-5.
Equals -3 minus 2 to get -5. The correct answer is B. All right, show of hands. How many people got that correct on their own? All 4 out of 4. Perfect. Good job.
Yeah, that's the only.
All right, we're on number 2. Find K such that all of that is continuous. All right, scale of 1 to 5. How hard was this for you guys? 5 being the hardest, 1 being super easy.
Mine was like a 4 because I can't remember.
4.
Just had a brain fart.
Brain fart. Okay, this seems like it was one of the harder ones. So I'm going to go ahead. Did anyone actually get this?
Yeah, I think I got it.
Tell us how to do it, Kaylin.
I don't know for sure, but okay, so like I first plugged in for the top. So
First plugged in for the top.
So 2 plus 3 equals 5.
Oh, you're plugging in the x value into the top equation, so 2 plus 3. You're taking this number x, this, what do we call this number? It's the,
The left limit.
yeah, this is the left-hand side, but this number, we call these two numbers, they're the same number, we call the something
the
specific.
Suspect point.
Suspect point,
Yeah,
beautiful.
So I did the left-hand suspect point.
What if they're different?
They will be the same. They can't be different.
Okay, so I got that. So then I know that it's 5. So then I set the right-hand limit equal to 5 because we know that they have to be equal.
All right, so I'm going to repeat what you said into the microphone so that we can hear. So you plugged in the suspect point into the left-hand side, and you know that the right-hand side must be equal to the left-hand side because we know, and I'm going to write this rule, that the right, R-I-G-H, right equals left equals what? What's the last one?
Oh, what was it?
Right equals left equals starts with a P.
I don't know.
No one? Go ahead and look at your notes. Right equals left equals something. I'm going to go ahead and write what Kaylin did after that, after you guys look for that. Kaylin said that the right
The first.
equals.
I forgot my
5.
notebook.
We need to bring our notebooks every day.
No, I
She
brought
brought her
physics.
Okay, need to bring calculus notebook every day. Right equals left equals.
Point.
You got it.
Point. Ow.
Good job, Isabel. Right equals left equals point. The point is where you have the equal sign, but we don't actually really need that right now because the point is the left. I mean, they're the same equation here. All right, so the right needs to be equal to 5. So what did you do next, Kaylin?
So then I plugged in the suspect point. So like K times 2 plus 6.
Okay, she plugged in the suspect point, K times 2 plus 6, and we know that's equal to 5. That's what you said already.
Yeah.
All right, so solving here, we do what? Someone else that's new. You had the equation.
6.
We're doing basic algebra 1.
So divide by 2
Divide by 2, Carly has it, and K
equals 1/2.
almost.
Negative.
Negative 1/2. Perfect. All right, so the review of this problem, the correct answer is A. The review of this problem is plug in the suspect point and make both sides equal to each other because right equals left equals point. Set these both equal to each other after plugging in the suspect point. That's all you need to do. and then solve, I guess.
Wait.
All right, I'm waiting for us to finish writing. Once I see that pens and pencils are done, I'm going to go on to the next slide. But before I move on, are there any questions? Can I clarify further?
No, I forgot. I just totally blanked.
That, yeah, I understand that we forget, so that's the reason that we're doing this. And then on top of that, we're going to do a pre-test on Wednesday. Also, announcement. Wednesday, that's 2 days from now. Today's Monday. If you guys can plan to come in after school, I know you have a volleyball game on Thursday, but on Wednesday, if you can come in after school to do the fix-up, that will be very beneficial. You can make your fix-up go up to 100%, and you'll be more prepared for the test the following day, which is Thursday.
Is there any way, like, from now on, we can try to do it, like, Tuesday or Thursday? Because we have running Monday, Wednesday, Friday.
I will try to plan around that. Thank you for letting me know. All right, no questions. I'm moving on to the third question. All right, when I take the limit as x goes to infinity, what am I really asking for? What type of asymptote?
Okay, wait, can you repeat that?
So when I take the limit of a function as x approaches infinity, what type of asymptote am I really searching for here? There's only two choices here.
Vertical? Horizontal.
Is it horizontal or vertical? Yeah, those are the two choices. So I hear Kaylin's answer.
Vertical.
Like,
I think it's vertical.
The correct answer here is horizontal.
Oh, because it's like that rule. And you do a magic fraction.
Yeah, so when I take the limit as x goes to infinity, I'm really asking where is the horizontal asymptote?
So whenever it says look the limit as x approaches infinity, that really means look for a horizontal.
Asymptote, exactly. In terms of a graph. In terms of the algebra that we do, what is it really or what are the steps that we do? There's three cases, right? Can you guys name the three cases really quickly? You don't have to tell me what to do in each of those cases, but what are the three cases when I take x goes to infinity?
That would be.
I'll do the first one. Actually, I'm gonna back up
Can
here.
I turn off the lights, please?
Please do. I should have done that. Turning off the lights. This is the first case. In which case the answer is infinity or really D and E.
And then it's bottom capitalized,
need
and
to
then
memorize
both of them are
those.
Yeah, so Isabel says bottom is capitalized,
and then top is lowercase, and then
top is
third one
lowercase.
Is both of them just the same?
So you're going too fast.
Isabel's saying both of them are the same, so top and bottom are both lowercase. All right, someone aside from Isabel, tell me what these are equal to. I know that the top one is D and E. This one is 0. Thank you, Kaylin. And this one, someone new? 1. I hear from Rosalie.
Magic fraction.
Magic fraction. That is the correct answer. Thank you, Kaylin. And what is a magic fraction? Someone aside from Kaylin?
You look at the exponents to see which one's like the highest one, and then you just take both of those, and then you just take the what's it called,
The coefficient.
the coefficient, and then just make it.
Good job. I'll repeat what Isabel said into the microphone. You look for the highest degree, or the one with the term with the highest exponent, and then you take the coefficient of both of those and turn it into a magic fraction. In this case, we are going to be in case 3 because you can see that the top and bottom power are the same, so we're using case 3, and we take the coefficient 5 and 4, or yeah, I did those backwards, but 5 and 4, and then you just make that the fraction. That's a magic fraction, so we have 5 over 4. The correct answer is D. Ask questions.
I just gotta process it.
Got to process? All right, I'll give it a little bit of time to process.
So remind me again, what if it were like 5, like what if 3 and 2 had exponents as well? Would you just...
So what exponents do you want to give 3 and 2 in your what if scenario?
Because if they weren't the same.
Like this, 2 and 2?
Yeah.
Someone else answer that. What happens if
Would it just be
these were
5
both 2 as well?
minus 3 over 4 plus 2?
What?
So Rosalie's saying, would it just be 5 minus 3 over 4 plus 2?
No.
Yeah, I think so.
Yeah.
Kaylin agrees, everyone else agrees, and I am also in agreement because what you're really doing is you're going to combine like terms before you even begin. 5 minus 3 is 2, or in your magic fraction, you left it as 5 minus 3. So in that what if case, where you have 5x squared minus 3x squared, and I don't really care about the rest, and on the bottom, 4x squared plus 2x squared, you can do it one of two ways. You can either turn it into a magic fraction immediately, in which case it becomes 5 minus 3 over 4 plus 2, or you can go ahead and combine like terms. In that case, it would be, oops, let me undo that. It will be 2x squared over 6x squared, and then again, magic fraction, 2 over 6. Again, it's going to be the same thing. Good question. I like that what if. That's the stage 3 and 4 level of thinking. 4 is the highest level of thinking that you can do.
Can't you simplify it to like 1/3?
Can't you simplify it to 1/3? Yes, you can. In fact, that's probably how they're going to be in the multiple choice answers. All right, questions on number 3 before we move on to number 4. We're going through these fast and furious, that way we can get to the next set of, what are these called again, self-checks. All right, number 4, for which of the following does the limit, okay, double-sided, single-sided, left, right, what is this thing?
Both sides.
Both sides, says
Call it
Rosalie.
again? Is that what you call it?
You can say double-sided or both sides. I understand what you're trying to say. Both of them I'll consider correct. So the limit as I go to some height f of x as I approach 3. So I'm talking about 3 here. Talking about 3 here. We can see where 3 is on all these graphs, more or less. All right, so as I get closer and closer to 3 from both sides, I need to be approaching the same value because, what is the rule? Left equals...
Right.
Okay, I apologize. Left needs to be equal to right. I was looking for a different rule there. I was thinking left equals right equals point, but that is only the case when you are doing something like this, where you're finding a k to prove continuity. Continuity always needs all 3 of them. Left equals point. But if I'm just asking for a double-sided limit, I just need 2. Left equals right. All right, so which one of these have a left limit and a right limit that are equal to each other? So A, someone talk to me about A. Why is A incorrect?
They never touch
That would be does not exist.
Yeah, that one is D and E for both sides. Kaylin has it. And Rosalie, what did you say? You said something else correct, I believe.
They never reach the same point.
Yeah, they never reach the same point. So continuous means that they connect somewhere usually. Well, yeah, it does mean they connect somewhere. And they don't. So both reasons exclude A. So it can't be A. I'm going to do a line through A. All right. So someone tell me why B is correct.
Breaking.
Why is B correct?
He's correct.
They reach the same point.
They both reach the same point. As I go from the left, Mr. Ant's height gets closer and closer to the value of 3. As I come from the right, Mr. Ant's value gets closer and closer to that same height, 3.
Can it also be C because they're both on the, or does it? Are you looking at where it comes through?
But they have to come
Y
together.
axis.
Okay, so the question was, why can't it be C since they both...
Like, they would come together once that one like goes up.
So let's take a look at that. The left limit needs to be equal to the right limit. So left is over here, right is here. So as Mr. Ant gets closer and closer to 3 without actually hitting 3, his height is what? It gets closer and closer to 1. So in this case, the right equals 1. Mr. Ant's height, as I go to the right from the left, gets closer and closer to the value of
3.
So you're always looking at height.
3. You're always looking at Mr. Ant's height. Yes, height.
So even if it is an open circle and it would technically like take you up to the other one, that doesn't mean that the limit is the same.
Exactly. Just because it comes up here, just because the actual filled in circle up here is the same, or just because it's connected to the left, it doesn't mean that the limit as I go from the right is equal to that point.
No, because it's like still as it's approaching, so like it doesn't actually.
Exactly. The key word is as I approach. So as I approach 3. Perfect. Okay. So C is not valid because the left and right are not equal. A is just D and E. The left, you can even write this in here if you want. Left equals D and E, and right is D and E. What about for D? Why is D also incorrect?
There's not a line.
Unconnected.
Exactly. It just ends, right? There's no line. So there's no Mr. Ant's height. So the right, I'm fairly sure this is D and E, although I might need to review that. The right, there's no limit. Like it doesn't actually approach anything. It's just there's nothing. But the left, it does approach something. The left approaches what?
3.
Left approaches 3. The height approaches E. height approaches 3. All right. Ask questions about this problem.
I thought there was something that was saying if you have like an open spot, there was something I don't really remember, but there was something about that.
Yeah, like
Something about an open spot.
Yeah.
So this is open right here. So it is not continuous because it's open, but the limit, the double-sided limit still does exist. Because remember, continuous, I think this is what you're saying, but you can correct me if I'm wrong, is left, oh, come on here. I'll make that into an F. Left equals right equals point. But
Oh.
the double-sided limit, so limit as x approaches some c without plus or minus, that means it's double-sided. All I need for that is left equals right.
Gotcha.
And that's what it's really asking for. It's not asking for continuous. None of these are continuous. All right. One more question. Someone do it. Or otherwise, I'm going to ask a question.
you can ask a question.
Okay, what is this thing called? What is this discontinuity? It is a discontinuity. Its type is
A vertical asymptote.
vertical asymptote. Good job. All right.
Nice.
Number 5. Which of the following is the value of, is this a double-sided limit, left-hand limit, or right-hand limit?
Double-sided?
I hear double-sided.
I'm sorry.
Wait,
Or,
can you?
yeah, it is because it's coming from both sides.
I'm just asking about this notation right here.
So.
Oh, yeah.
Is this double-sided left or right?
Double-sided.
It is double-sided. Why is it double-sided? Someone else.
Because there's no negative
Exactly. There's no negative or positive
or positive.
to the right of the 4. All right, so it's looking for the double-sided limit. So again, we're looking for whose height? It's kind of a dumb thing that we use. Mr. Ant, yeah.
I love Mr.
He's cute. Okay, so Mr. Ant's height, this guy, his antenna and stuff, he's getting closer and closer to what point from the right? He's getting closer and closer to 6. And Mr. Ant's height from the left is what?
2.
It's 2. All right, and what do I need in order for the double-sided limit to exist? I need,
Equal each other.
what needs to equal each other?
Left and right.
Left and right need to equal each other for the double-sided limit to exist. So the left is 2, the right is 6. This is not the case, so the answer is D and E.
I thought I did really well on this, but I actually only got 2.
All right, are there any questions from any of these problems before we go on to self-check 1.2?
Yeah, so for this one,
Wait, yeah, can you explain this one again?
All right, someone else explain this one.
What I did? Oh no, I didn't get this
So
one.
when you're always doing a double-sided limit, the left and right need to equal each other, but or the heights of the left and right need to equal each other, but they don't because you have the right one equals 6 and the left one equals 2.
And so it's
it does-
automatically DN.
so like this is kind of the same mistake.
Well done, yeah.
as the other one where like the limit, even though it's an open circle, the limit is still where the open circle is.
The limit is
It's, like,
still,
as you-
yeah, exactly. It's where you approach. So 3.5 is never correct for a limit.
Every single time I hear limits, I
Yeah, I like.
So I'm gonna write here.
Now I'm like wondering what that problem was like. Maybe I probably.
I'm going to ask one question of you guys. How do I get to 3.5? Because I can never get there using a limit. How do I get to 3.5? What is the symbolic representation to get the height of 3.5?
Oh, is it a discontinuity or?
This is a discontinuity right here, but how do I get 3.5? So if I give you some symbol in that box, the answer here is going to be 3.5. What is the symbol notation in order to get 3.5? How do I say a point? Not a limit, but a point. How do I get a height?
It has to be. Oh wait.
A continuous, right?
So does it have to be? Is it?
I mean, if all
have to be-
three were equal to each other, equal to the point, then it is continuous, but this is not continuous. I'm just asking from this function exactly, EVT is not applied at all, because
So
EVT
wouldn't work because it's not continuous.
EVT would not work because it's not continuous. I agree.
Okay. never mind.
Was
Everything you're
this
saying
whole
is correct. I
worksheet
like it.
dealing with EVT?
Say that again?
Was this whole worksheet dealing with EVT?
None of this dealt with EVT, because EVT proves two things. What are the two things?
Continuous and
It proves two things.
Minimum and maximum.
Minimum and maximum, right? All right, I'm going to give this to you because we're not getting it and we need to move on. But in order to get a point, you just say f of a value. So f of 4.
Oh my god.
So that's how you get a point. This is a point. That's what it translates to. F of 4, the point at 4. or the height at 4. This really translates, the height at 4 is 3.5. All right. With that, I'm going to go ahead and end the video, and then we're going to move on to self-check 1.2, again, 10 more minutes.